Hello. Yeah, in this presentation, I want to give you a walkthrough on how to approach the Chapter 9 comprehensive problem. I know the problem seems to be tricky in the sense that the values needs to be entered in a particular way. So there is no much flexibility when it comes to working through some of these problems. So let me take you through the first problem and maybe the second problem. So the first problem of the comprehensive problem, you've been asked to compute the present value of $4,800 that is basically paid in 2 years using the two discount rates. So the first discount rate, which is for first year, is 8% and 7% for the second year. So in order for us to solve the problem, what we need to figure out is, again, I always like to use the timeline because the timeline it just gives me a clear understanding of the problem. So in this problem, again, quickly, we talk about a period of 2 years here. So 1 year and the second year. And we talk about a future value 2 years from today. This is given to us from the problem. 2 years from today, the future value is $4,800. And the rate for the first year is 8%. So here it's 8%. And here it's 7%. So what this question is asking us to find, of course, is to at last is to find the present value, which is at time 0. But then we are also being asked to determine the value of the $4,800 a year from today. So in other words, it's like you're looking at a present value, a year from today. So in other words, you're going to discount the $4,800 to year one and then discount this amount again to at time 0, where again the only difference is you're going to use different rates, 8% in year one, 7% in year two. So to use the Excel to work through this, again, I'll just take you through this. And we have to reference as many cells as we can reference. Otherwise, if there's no information to reference, you'll have to enter this information in in Excel. So, for example, in this case, is the value 2 years from today. We know that 2 years from today, we expect to receive $4,800 in 2 years from today. Therefore, this is the same saying that the value 2 years from today is the same $4,800. So there's no question about it. And the second part of the problem is the value 1 year from today. So what the question is asking us is this: is the present value of this $4,800 a year from today, which is a year from today is here. So at this particular point, what's the present value of this? So the future value is 48. We need to find the present value a year from today, where of course n is 7, and of course n is 1, and the rate is 7%. In that regard, then we're trying to find the present value. So what you do again, you'll do the present value of, we are looking for present value of the $4,800, a year from today. So this will be again equal to the present value. Our rate here is the 7%, which is the rate for the second year. So again, you're going to reference the rate is 7%. The number of periods here, again, is just 1 year. Because you talk about, discount of $4,800 to year one. So our N is just 1. There is nothing for us to reference in terms of that 1. So what you'll do, you'll have to key in 1. And then the payments, again, this is not there's no payments involved here. So this is not like an annuity problem. So what you do again, you could just put 0 there, or you could skip and just add an additional comma. So what I'll do is I'll just put 0 there. but you could just add a comma there to represent that zero. So I'll do 0, and the future value for us is the $4,800. Again, in this case is again negative. The 48 again is given to us here, so you're going to reference the 48. And the type here again, we know that if the payments are at the end of the year or at the end of the period, then of course we use 0 as default. If not, if the payments are at the beginning of the period, then of course you use 1. So in this case, again, by default is at the end of the period. So again, you could just enter 0 or you can ignore that. So I'll do that and you enter, and that gives you the present value a year from today of that $4,800. The last part of this is to determine the present value. Now you can determine the present value of 48. So here again we know that this value is 44.85 and 98. So what the question is asking is to discount this back to present. Again, to do so, where again this is at 8%, again our n is just 1 year. So in this case your n is just 1 year. So to do so, again what you'll do is you'll take equal to the present value, and our rate here again for year 1 is 8%. So you're going to reference the 8%, and then your number of periods again is 1. There's no reference point, so you just enter 1, and the payment in this case again is by default is 0 because there's no payment we are making here at the end of the period, so there's nothing involved here, so it's going to be 0. And the future value to us is going to be what we just found out from the previous problem. So our future value will be the 44.85. So what you'll do again, you reference the 44.85, and by type again by default is 0, and you do so and you have the problem solved. So again, the trick part is just to make sure you reference in what you need to reference, and again there's no flexibility in terms of making changes. I know if this was a normal Excel, you'll have more room for flexibility, but in this case you just don't have. So let's look at the next one. With the second problem, what we have is we are being asked to determine the future value, and again you must enter all your answers as as a formula. In the second problem, being given someone is making contributions of $330 per month to a retirement plan for 15 years, and then you increase those payments later on to $530 for the next 25 years. So again, the question at 8% rate, the question again is how much will be what will be the future value of those contributions at the end of the first plan or set of contributions, and then of course what about at the end of the second set of contributions. So again, if you think about it, if you draw this on a timeline, again you're talking about a case of 15 years and a case of additional 25 years, so you end up getting to 40 years. So again, these contributions are done on every month. So even if this was year 1 and this was year 2, you're making contributions every month, but how much you're contributing? In this case, you're contributing 330. After 15 years, you're going to increase your contributions from being 530 to 530. So you add $200 more, and that'll be a case of 16, and you keep on going all the way to 40. So the question is asking us is to find the first set of contribution, which is basically at the end of the 15 years. So what will be the future value of these payments? Remember, these payments represent an annuity problem because you're making a set of same payment all the time. So this represents an annuity problem. So for the first set of contributions, the 330 each month for 15 years at again at a rate of 8%. So in this case, our rate is 8%. And this 8% per year. Remember, we need to determine the rate per period, because if we have to use the formula or what we know from the chapter, we cannot use 8% because 8% represents a rate per year, and you're making payments on a monthly basis. So if you think about here is the future value. So we are looking at the value at the end of the first set of contributions, which is basically at the end of the 15 years. So, and therefore we are looking at a future value problem. So the future value of those series of payments, again, this is an annuity problem. So the future value, again, the rate for us here is 8% per year, but per period, because we have 12 periods per year, and therefore we need to determine our rate per period. So our rate per period is going to be, we take the rate per year, which is again reference the 8%, but then we need to divide this with the 12 in order for us to find the rate per period, which will be 8 divided by 12. In this case is D11. That's the sale for 8% divided by 12. And then the number of periods, again, remember we're talking about 15 years and the payments being done at the end of every month. So in this case, the total number of periods are going to be, we reference the 15, the number of years is 15 years, times then, because there's no 12 for us to reference, times 12, that represent the total number of periods. And then the payment for us here, again, you're paying $330 for the first 15 years. So you're paying, that becomes a cash outflow, and therefore this will be minus 330. 330 is given to us. We reference 330. And then our present value in this case again is 0. We have no present value for this. So that will just be 0. Again, that would be just be 0, nothing else there. And that type here, we're assuming the payments are at the end of the month, at the end of the period. So in this case, by default, again, this is going to be 0. And you just close your parentheses and you enter. And therefore, the future value of those contributions by the end of 15 years, you'll have 114,192 and 61 cents. The second part of the problem is the value at this the value at the end of the second set of contributions. Again, I'm assuming you can do this, because remember now what you have done this. So now we know that at the end of 15 years, we have 114 here, 192 and 61. And this number basically is representing, if you're thinking, if you're looking at this problem from 15 years to 40 years, so we have an additional 25 years here. So we have an additional 25 years here. And so this represents a present value. If you think about it, this represents a present value, where n again in this case will be 25 years, and again this is a payment per month, but it will be 5 for 530. So what we are trying to find out again, it will be the future value. So the future value here, what you're going to, the future value again will just be, you'll determine the rate. So you're going to look at the rate per period, and then the number of periods, your n, and then you're going to enter your present value, and then you'll enter, of course, the type and the format and so on. So to do this again, what you'll do, I don't want to show you this, but just to show you quickly, what you're going to do is to determine the future value for this problem. What you'll do, you're going to enter the rate, and the rate again here, remember we're talking about 8% divided by 12. So again, what you'll do is you take 8% and you divide this with the 12. That way you have a rate per period. And then your number of periods, again, remember we talk about from 15 years to 40 years. So for the next 25 years, so we talk about 25 years. So what you'll do again, you reference the 25 times, of course, your times 12. That gives you total number of periods. And then your payment, remember, your payment goes up. So your cash outflow is 530. You reference 530. And then what you do is your present value. Remember, your present value will be now be this. So the 114 becomes a present value. So your present value is 114, and the type, again, the assumption is these payments by default are at the end of the period. So the payment is going to be the type is going to be 0, and then of course you enter and you'll have a value for that. Again, that's just another way to solve these problems. Then the next problem, which I don't want to go through, but I just want to point out to you, is the question 3. Now, question 3 is different in the sense it's asking you to find the it's asking you to find the the rate. So again, you know that through Excel, what you can do again, what the question is asking you is to find the rate. So we need to determine the number of periods, the payment, the present value, the future value, the type, and of course we close the parentheses, and that will give us our rate. In this example, for example, we know that the the you earned $5,000 invest. So what annual rate are you going to earn on a $5,000 investment when it grows to 10,750? So again, if you just think about it, if you're going to use again a timeline, we are looking at an investment of $5,000 here, and this amount grows to 10,750 over a period of, again, this is a period of 6 years. So 1, 2, 3, all the way to this will be 6 years. And so we don't know the rate, but we know this amount will grow from 5,000 to 10,750. So we know that our N is 6. What we don't know is that rate. So this is what we are looking for. So what you do is the number of periods we know is 6. So you'll enter that to be 6. Again, you're going to reference the cell is 6. And then the payment, again, there's no payment involved here. So it's going to be 0. Our present value is going to be 5,000. So our present value is 5,000. And our future value, we know that the future value is 10,000. And again, we're going to assume here by default, I think I'm missing something. The rate is 9, so it's 9. So the periods are a D9. Then I have 0. So let me just go back this. I think I'm missing something. So our number of periods are a 6. And then our payment is 0. And then the present value is 5,000. And then the future value is 10. And then by default, again, by default is 0, assuming the payments are they come towards the end of the period. Again, by default this is going to be 0, otherwise we have to put 1 there. So in this case is 0, and again you close the parentheses, and this will compute the annual rate, which in this case again is going to be 13.61%. So I hope this information helps, even though I know that I was able to walk through all the problems. but I'm assuming it gives you an idea on how to approach uh, time value problems using Excel. I know, again, the way it's set up, it's a complex process. It's not as flexible as it needs to be. So, but I hope this information helps. So let me know if you have any questions on the homework problem, and feel free to either email me, uh, and I'll be happy to help. Thank you.